In episode 28 of Mobycast, we continue our conversation on VPC setup on AWS. In particular, we discuss availability and security considerations. Welcome to Mobycast, a weekly conversation about containerization, Docker, and modern software deployment. Let's jump right in.
Welcome, Chris and Rich. It's another Mobycast.
Hey.
Hey, Rich.
Hey. So, this week we have a lot to talk about because last week we started getting into what it takes to set up a VPC for ECS on AWS. That's three-letter acronyms in one sentence. And turned out that there's a lot to talk about in there. So as interested as I am in what you did this past week, I think we should jump right in. So where we left off last week is that we were talking about attaching an internet gateway to your VPC. And then we started talking about routing tables a little bit. And then that got us talking about just the importance of TCP/IP, understanding TCP/IP networking in general, and how it always comes up. It comes up in your daily life at home, dealing with your computers, to dealing with AWS, to dealing with stuff in the office and your programming and everything. It just always comes up. And the more you know about it, the more valuable of a software engineer you'll be. And so I think as we continue, we want to be careful to make sure that we define everything and talk about things that make sense. But we do assume that if you're listening, you have some familiarity with TCP/IP networking. So we'll try to keep our definitions and conversation to AWS specific stuff instead of kind of doing a networking fundamentals podcast. So with that in mind, I think the next thing to talk about is it network Ackles, or are we going to talk about Nat Gateways?
We were kind of doing a broad survey of just all the various players that go into a VPC and its creation and management. So we talked about subnets, routing tables. We talked about what an internet gateway is. Mm-hmm. Another piece of that is a NAT gateway.
Okay.
And so NAT stands for Network Address Translation. And in addition to NAT gateways, some of the other major players in this would be just some of the security considerations, like what are network Ackles versus security groups. And I think that will round out like the primary components of what makes up a VPC. And then after that, we can kind of start diving into more about like, okay, how do you start applying these things, and what are some of the security considerations and availability considerations, as well as just best practices for like, how do you ideally set this up, especially with we'll focus on when you're running your workload on ECS. So what's a best practice for that?
Let me interrupt real quick because I want to set it up just exactly the way you had set it before, which is that we had set up our subnets, and you were saying there's got to be a way to talk from the subnet out to the network, and there's got to be a way for the internet to talk. If you want the subnet to be available from the outside world, there's got to be a way to talk from the outside world to the computers inside the subnet. So the way out was the internet gateway. That's how the computers on the inside of the subnet can talk out to the World Wide Web and the internet at large. And then the NAT gateway is how they can talk in. So what more can you tell us about NAT gateways and setting them up?
Right. Yeah. So NAT gateways are for basically NAT is when is essentially a firewall. So it's where you want the stuff that's behind the firewall to be able to make outbound connections, but you don't want to allow any inbound connections, right? So network address translation, it's really kind of what it implies is that you are translating an address from a private one to a public one, essentially, in order to allow it to talk to the outside world. And so a NAT gateway again becomes important as part of your VPC when you have just resources that you don't want to be directly accessible by other machines on the open internet, but yet it still needs to go access the internet itself. right? So this could be like, you can think of it, maybe you have like a database server that you don't want your database server to be directly hittable by the public internet, but maybe it needs to go have network access to download updates because you're running Postgres and you want to get the latest build of Postgres or something like that, or you need to get patches or whatnot. So it needs internet access, and so a network, a NAT gateway would provide that functionality that you need and that security. So kind of think of it as a firewall, as a proxy. It's basically doing some, that proxying is doing some translation. So we're saying, hey, I know you have this public IP, which is not addressable from the internet. I'm going to basically keep a mapping of your private IP to a public IP, and I will do the communication on your behalf.
Right. So with the Internet Gateway on AWS specifically, that was a managed service that AWS provides. So you don't even have to think of it as a computer that you're configuring. What about with NAT Gateway?
Yeah. So there's two kind of flavors of this. One is NAT instance, and then there's the idea of a NAT gateway. So NAT gateway is something that's relatively new. We're again kind of like value-added service added by AWS to make life easier for you. So it is something that's out of the box, makes this process a lot easier to set up. In the past, you had to deal with basically a NAT instance, in which case it was much more manual, where you would basically build your own NAT functionality by spinning up an EC2 and doing the enabling the port, basically the port forwarding, and just manage that all yourself. And so you had to worry about things like throughput and, did you have a big enough EC2 that can handle the network load and whatnot. So that's a NAT instance. Luckily, we really don't have to do that. There's no reason to do that anymore. You can use a NAT gateway. But the issue with the NAT gateway is NAT gateways are they're per availability zone, in that you have to put them onto a subnet. So what that means is it does mean there's some additional complexity there to kind of make sure that things are going to work when an availability zone goes down. And so this is actually one of those things that I think a lot of folks don't really think through and realize what the implications are. They'll just set up a single NAT gateway, assign that to a routing table that becomes essentially a private routing table, and then everything works and they're fine. And they may very well have multiple subnets spread across multiple AZs, but they're still not fully available because that NAT gateway, if that availability zone in which the NAT gateway is assigned goes down, then that means now all of their NAT functionality is broken. It's not going to work. So
I was listening to you, but I missed one part. Did you say that NAT gateways only work per availability zone or that you have to have one per subnet?
It needs to be assigned to a subnet.
Okay. So if you have multiple,
by virtue of that, it can be assigned. It has to be assigned to an AZ.
Hey, this is Rich. You might recognize me as the guy who introduces the show, but is pretty much silent during the meat of the podcast. The truth is, these topics are oftentimes incredibly complex, and I'm just too inexperienced to provide much value. What you might not know is that John and Chris created the training product to help developers of all skill sets get caught up to speed on AWS and Docker. If you're like me and feel underwater in these conversations, head on over to prodockertraining.com and get on the mailing list for the inaugural course. Okay, let's dive back in.
Right. But again, you can have multiple subnets inside an AZ. I don't know necessarily that you would typically do that, but if you did have multiple subnets inside one single AZ, you would need to have a NAT gateway per subnet that you wanted a NAT gateway on, right?
So no, you just need, so you can think of it, you need to have a NAT gateway. It needs to live somewhere. In AWS's case, you need to assign it to a subnet, so it's going to live in a specific AZ. You can now have a subnet in some other AZ talk to that NAT gateway, right? You don't have to define it each subnet doesn't have to have its own NAT gateway. So you can have 16 subnets in a single NAT gateway, and that's perfectly fine. And that, again, this is like the common scenario. This is what most folks do. Right. So, but the problem is that if you're in a region with, say, 3 AZs, and you have, call it 6 subnets, there's 2 subnets in each one of the AZs, and you've created a single NAT gateway that sits in the AZ1, and so now you have the subnets and spread across AZ1, 2, and 3. They're all using that NAT gateway that's in AZ1. If AZ1 goes down, you did the design so you have the other 2 AZs are still up and working, but the problem is now when they go try to access the internet, they're not going to be able to, because your NAT gateway was in AZ1 and it went down. So even though you did some design to make yourself available when AZs had failures, you had a single point of failure basically with your NAT gateway.
Right. Now it's clear.
Yeah. So the way around this is you basically define a NAT gateway for every AZ.
Right.
So then you end up having separate routing tables for every AZ.
Makes sense.
So if you're spread across 3 AZs, you'll have 3 NAT gateways and you'll have 3 private routing tables.
Got it.
And then you're as available as you can be. So that way, if failure in AZ1, that just means whatever's in AZ1 will be affected, but AZ2 and 3, they'll still perform just as without a hitch.
Right on. Yeah, that makes sense.
So that's a bit about NAT gateways. Rounding out the components of a subnet that are kind of important would be network Ackles and security groups. And I think we'll get more into this a little bit later as we dive into some of the security considerations for how to set it up. But this might be a good time to talk about, just at a broad level, network Ackles. They're being applied across the VPC and across every subnet. They're also, these rules are stateless. So every request, every network request has 2 hops to it, right? It's the inbound request. So you're going from, computer A talking to your computer B. So that's the first hop. Your computer B receives that request and then responds back to it. So it's the request and the response. So with network Ackles, you define the rules for both the request as well as the response. And so it's called a stateless rule because of that, because it does not remember in the settings of what it was on you can have different settings on the response versus the request.
Okay.
With security groups, they're stateful. So you have the one rule that basically is for both. It applies to both the request and the response. So that's one of the big differences between those two. The other thing is that security groups are much more granular. And so you can slice and dice and have much more fine-grained control. Network Ackles are really good if you just want to have kind of like VPC-wide rules to allow or disallow certain types of traffic patterns. So you can block traffic from a certain IP range, or you can say, what, we're not going to allow any SSH on this VPC. So we're just going to block port 22 is blocked, right? It's just right. For the entire VPC. And so that's when network Ackles come into play.
Okay, that makes sense. Yeah, you'll use network Ackles and security groups to secure your VPC. So we've kind of talked about all the parts and pieces. Maybe we have a few more minutes. We can start putting it together a little bit.
Yeah, I think now we've touched a little bit on availability considerations. So, you do want to be spread across multiple AZs. Mm-hmm. We talked about internet gateways, how like that's kind of a fully managed service. Don't need to worry about that. NAT gateways, you do. Those are basically 1 per AZ. And so you just need to do a little bit more work to make sure that is as available as you can be. We've talked a little bit about security.
That does seem like sort of a good way to kind of to wrap it up a little bit. Maybe we can say for availability considerations, we talked about needing, we talked about all those three things, that multiple AZs, the internet gateway, and the NAT gateway. But maybe we could just quickly define a minimally highly available VPC. So that would be, it's got to be in one region. It's got to have at least 2 availability zones. It's got to use an internet gateway if it needs to talk to the outside world. And then it's got to have at least 2 NAT gateways because it has 2 availability zones. Is that sort of minimally highly available?
Yep, I think that covers it.
Okay, cool.
Yep.
All right, so we actually still have time, so keep going. You were about to get into security considerations?
Yeah, I think, so we've talked a little bit about network Ackles and security groups. Again, those are, we could dive really deep and spend a lot of time on that. And I think we'll save that maybe for some other day.
Yep.
But one of the, maybe the important considerations that come out of kind of like what we've talked about so far is, and you'll hear this a lot, is the idea of a public versus private subnet.
Yes. This is so tricky for people, I think.
Yeah. And it's so key. It's so fundamental, right? So it's this idea of basically in general, a public subnet would be a subnet where the routing table allows internet access coming inbound from the internet. So it's directly accessible from the internet. So that's why it's called public, right? It's publicly accessible. And so, if you have resources that need to be directly addressable from the open internet, then you're going to be putting making sure those resources are on a public subnet. A private subnet, right, would be those resources that should not be directly accessible from the internet, and they may or may not need to have access to the internet themselves to do outbound requests. But this is definitely one of those fundamental design considerations that you're going to want to have separate your resources into public versus private. You'll want to set up public versus private subnets, and the same rules about availability apply here as well, right? So if you're going to have if you're going to have both public and private subnets as part of your architecture, then you're going to want to spread those across availability zones. And so if you're spreading across 3 AZs, you may very well end up having 6 subnets at a minimum,
right?
Because you're going to have 3 public subnets on the 3 different AZs, and then 3 private subnets on each one of the AZs.
And I remember having a conversation with you a while back, Chris, about this public versus private subnet thing, because one of the things that happens is you'll make a mistake setting up your VPC or your subnets, and you'll end up in a situation where you're trying to get to a database, or you're trying to get to a machine and you just can't seem to get to it. And it's like, why can I not? I'm on the AWS console and I'm right clicking and I'm saying, connect to this computer, and it just doesn't work. And it's like, what is going on? Why is AWS broken? And the answer might be that there's no route from the internet to that private subnet. And AWS isn't telling you that because it doesn't know that. All it knows is that there's a computer there, and typically if there was a route to it, this is how you would connect to it. And I remember sort of saying, why can't AWS make this easier? Why can't it make it, a big red, hey, this is not publicly available, this is on a private subnet thing on there? Remember that conversation?
I do, yeah.
And it basically came down to just, it's sort of too tricky. Like the fact is that it's a routing table that needs to have a route into the subnet and not a property of the subnet itself.
Correct. Yeah. I mean, there's no button in the AWS console that says create public subnet or create private subnet. Right. It's this is just the convention of what public and private subnets mean. So it's very much just a networking architecture consideration type thing. And it's just a way for you, just a best practice to set things up so that you are giving the least amount of privilege and access that's necessary in order for your system to work, and then also to make sure that you're as secure as possible. And the other thing that complicates, like what you talk about, about like computer A trying to talk to computer B and it can't get there because of a route. It's not just the route that could be in play. It could be the network Ackles are preventing that access. It could be security group is preventing that access.
Yeah, and that's what I was going to get at is like when you're creating an EC2 instance and you say, well, this is the security group that I'm going to use, for this EC2 instance. One of the things that can trick you into thinking that the thing should be publicly available is that you might crank that security group wide open. So, hey, anybody can talk to this computer. It is available. But still, if there's no networking route from the internet to that EC2, it can be wide open and you still can't talk to it. And I think that catches more people than just about anything else.
Yeah, absolutely. I mean, there's a lot of layers here.
Right.
And any one of those layers, if it's not configured the way that you need it to be, it's not going to work, right? So it's like you can think of it as like just switches, and there might be 3 switches, and they all have to be in the closed position in order for you to have connectivity. And if any one of those switches is open, it's just not going to happen. No connection, right? Mm-hmm. So,
and some of them are sort of surfaced by the AWS console, and others are things that you need to be aware of when you're creating your VPC.
Mm-hmm, absolutely. Yeah. So that's kind of in general public versus private. So by default, like when you create a new subnet, it's going to be a private subnet because the routing table won't have the path to an internet gateway defined. So if you want something to be public, like we said, you'd set up an internet gateway and you'd add that to the routing table used by that particular subnet. So that now you have both inbound and outbound internet access. For your private subnets, if they don't need any internet access whatsoever, then there's nothing you need to do, right? You just leave them alone, and they basically can only talk to other machines that are there within the VPC. If those machines need to make outbound requests to the internet, like to go download patches or to make API calls to other services or whatnot, what you'd need to do is use a NAT gateway. And so you would update the routing table such that the machines inside that subnet have a route to the NAT gateway. The NAT gateway needs to be on a public subnet so that it can now go talk to the outside world. Mm-hmm. So, it's one of those things where at the end of the day, it ends up being pretty straightforward and simple, like what the difference is between a private and a public subnet and how to create them and, what it means, just the practicalities of setting that up. But I think it's also one of those things that maybe a lot of people don't think through and understand how it works. So it's kind of good to talk about.
Great. I think that can kind of wind up our conversation for today, and hope that people were able to follow us without whiteboards and diagrams, because this is tricky stuff.
Yeah, and I think it sets us up, I think, for next time to kind of start bringing this all together and how does this relate to, actually now that we've set up the infrastructure, now that we've built the condominium building and we've laid in the utilities and we have electricity and plumbing, how do we move in our folks and actually start running our ECS workloads in here? And now the practical day-to-day use, how do I connect to those machines if I have to do debugging? And what does that mean if they're on a private subnet? So we can get into all that.
Well, thank you, Chris. Thank you for educating us. And thank you, Rich, for producing this episode. Talk to you next week.
Great. Thanks, guys. All right. Bye. Bye.
Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/28. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.